So, good morning to all. Today we are going to discuss in our subject water resource engineering under the topic of in our unit 1 precipitation and abstraction, spatial analysis of rainfall data using Thiessen and Isohyet methods. So, the course outcome of this class build the knowledge of various components of hydrological cycle that affect the movement of water in the earth. The course outcome CO1 is correlated with the program outcome 1 and then 7 with the program specific outcome 1. So see the rainfall data analysis. Okay, so the rainfall, snow, sleet, hails, dew, mist. Okay, so the types of precipitation. From here, the rainfall characteristic based on the depth, duration, intensity, rainfall frequency. The rainfall data analysis. The plot rain hydrograph and rainfall data normal ratio quadrant methods. So from here, we can calculate through the arithmetical method, Thiessen polygon method, Isohyet method. We can find the intensity of the rainfall also. So the consistency test of rainfall record using double mass curve methods. So the precipitation is any dump or deposition in solid or liquid form that organized from the originator from the atmosphere. So the most come from the sea occurs when water vapor cools. So when the air reaches saturation point, also known as condensation point and dew point. So the water vapor condensates and forms tiny droplets of water. The precipitation form a 0.001% of the world water resources. Type of precipitation: horizontal precipitation, vertical precipitation. Water vapor become freezer near the surface or directly at the surface. Example: dew and fog. Whereas the vertical precipitation, water vapor become freezing on the air and fall to the earth. Example: rain and snow. The rainfall. Rain is the measure from precipitation in the form of water drops sizes greater than 0.5 mm. The maximum size of raindrop is about 6 mm based on the intensity. Rainfall is classified as light rain less than 0.5 mm to 5 mm for hours. That is the moderate rain 2.5 to 7 mm for hours, and heavy rainfall is greater than 0.7 5 mm per hours. The rainfall. So see the temperature profile based at the 0 degree Celsius, 32 degree Fahrenheit, in minus 20 degree Celsius, also 20 degree Celsius plus or minus based the snow. So from we can expect that minus 10 degree Celsius, snow melt. Here is the 0 degree Celsius. The rain is the 15 degree Celsius. So the cyclone rain, warm front, then cold front. So see the warm air, which is the cold air, or cyclone will be formed with from where the contours based we are formed. The cold air with the cool air are accumulated. The precipitation will be occur. The hurricanes and the tropical cyclone formation. So see the high wall, high, then rain bands. So fully formed tropical cyclone with an high wall and circulating rain bands. Convectional rain. So the direction of storm movement, the cold air, cool air, the moderate to light showers, warm front, here the cold front. So the warm air cumulus the clouds. So the conventional precipitation results from the heating of the earth's surface that causes air to rise rapidly. As the air rises, it cools and moisture condenses into cloud and precipitation. This type of precipitation is common in the drier provinces. So the conventional precipitation, cooled air condensing, so moist air, host surfaces, moist air. So stage 1, the sun hits the ground and warm air rises. As the air rises, it cools and water vapor condenses to form clouds. When the condensation point is reached large, cumulus clouds are formed. So heavy rainstorm occur. This usually included thunders and lightning due to the electrical charges created by unstable conditions. So see the conventional rain. So warm front to cold air. So the orographic, the stage 1. Warm wet air id forced to rise over high land. As the air rises, it cools and condenses. Clouds form and precipitation occurs. The drier air descends and warms. So any moisture in the air, example cloud, evaporates. So the orographic precipitation a result when warm moist air of the ocean is forced to rise by large mountains. As the air rises, it cools, moisture in the air condenses, and clouds and precipitation result on the windward side of the mountain, while the leeward side receives very little. Rain measurement. Okay, so these are the way we can find the simple rain gauge station, a standard rain gauge station, tipping bucket rain gauge stations. So rain measurement. Okay, so when 1 inches of rainfall into first bucket, it tips due to weight of water and empties into the cylinder. A second bucket moves into place to collect water and the process is repeated. The number of tips is recorded electronically. So the rain measurement methods, modern tipping bucket rain gauges, a commercial tipping bucket rain gauges. Rain measurement, alert, Penuket, Fusion, data, longer. So the rain measurement through the rain gauge. So weather station, rain count, funnel, reed switches, then magnet, small bucket. Rain, here it drain works are placement of rain gauges. The gauges are affected by wind pattern, edges, trees, and the gauge itself. Therefore, it is important to have the gauge located and positioned properly. So 1 meter above ground level is standard. All gauges in a catchment should be the same height. 2 to 4 times the distance away from an isolated object, such as a tree or building, or in a forest, a clearing with the radius at least the 3 height or place the gauge at canopy level. So the shielded to protect gauge in windy side or its obstructions are numerous. They will reduce the wind speed, turbulence and eddies. So see the wind based the gauge without shield. With the shield the gauge wind are occupied. So the rain gauge with the wind guards. The placement of rain gauge. For sloping ground, the gauge should be placed with the opening parallel to the ground. The rainfall catch volume mm3 is then divided by the opening area that the rain can enter. So the gauge opening area. Okay, so actual area of opening that rainfall can enter. So area is equal to pi into cos angle into radius whole power 2. The number of distribution of gauges need to consider size of area, prevailing storm type, form of precipitation, topography, aspect, season. So the number of gauges 2, we can expect the size of the area is 16 hectares. So 3 means we can expect 40 hectares. So up to 1000 plus, so 16,000 kilometers square. Whereas the snow is a form of precipitation within the Earth's atmosphere in the form of crystalline water ice consisting of a multitude of snowflakes that fall from clouds. Since snow is composed of small ice particles, it is a granular material. It has an open and therefore soft structure unless packed by external pressure. So snowflakes come in a variety of size and shape. So types which fall in the form of a ball due to melting and refreezing rather than a flake are known as gravel with ice pellet and snow grains as examples of gravel. The snowfall amount and its related liquid equivalent precipitation amount are determined using a variety of different rain gauges. So the temperature profile based. So the slit. So see where the temperature based 20 degrees Celsius the snow are formed. Slit. So slit refers to two distinct form of precipitation. So rain and snow mixed, snow that partially melt as it falls, whereas ice pellets one of three forms of precipitation in a US style winter mix, the other two being snow and freezing rain. So slit based. So see the slit forms when rain passes through a cold layer of air and freezes into ice pellets. So this occurs most often in the winter when warm air is forced over a layer of cold air. Sleet is minus 10 degrees Celsius. And snow melt, rain freeze, silt are formed. Hails. So hails is a large frozen raindrop produced by intense thunderstorm where snow and rain can coexist in the central updraft. As the snowflakes fall, liquid water freezes into them, forming ice pellets that will continue to grow as more and more droplets are accumulated. Upon reaching the bottom of the cloud, some of the ice pellets are carried by the updraft back up to the top of the storm. So the depth is water in the form of droplets that appears on thin, exposed object in the morning or evening. As the exposed surface cools by radiating its heat, atmospheric moisture condenses at a rate greater than that at which it can evaporate, resulting in the formation of water droplets. Even temperatures are low enough, they takes the form of ice. This form is called frost. So frost is, however, not frozen dip. So mist or fog. So mist is a phenomenon of small droplets suspended in air. It can occur as part of natural weather or volcanic activity and is common in cold air above warmer water, in exhaled air in the cold, and in a steam room of a cinema. It can also be created artificially with aerosol canister if the humidity conditions are right. So see the rainfall characteristic depth. The measurement is high. Rainfall measured in mm at centimeter, measured by the hour, day, week, month, and then year. Whereas the duration, the period of time during which rain fell, a rain time interval fall measured in minutes and hours. The intensity, depth of rainfall per unit time, example 30 millimeter in 3 hours, intensity is equal to 10 millimeter per hours. The rainfall frequency, the frequency of rainfall occurred, repeat for the rain. This situation can be illustrated by the rainfall that is uniform distribution, suitable for agriculture and reduce erosion. Distribution of single mode rainfall in the season and distribution of dual mode. So see the rainfall intensity. Intensity or AV rain is the depth of rainfall per unit time. The symbol is I and the unit are millimeter per hours at centimeter per hours or in inches per hours. So the rainfall intensity I is equal to depth of rainfall divided by time, whereas volume V is equal to area into depth meter cubes or feet cubes. So see the rainfall intensity, whereas the fog to cloud burst. So the intensity inches hours centimeter per hours based. The fogginess 0.005 as the median diameter 0.01 as the velocity of fall feet per second is 0.01 as the drop per second per square foot is 6,264, 000. So the rain average in precipitation is non-uniform and the rain gauges are unevenly distributed within the area. The precipitation at each gauge may be weighted in proportion to the area the station is assumed to represent. So the method used to convert point rainfall value at a different rain gauge station into an average value over a catchment include like arithmetical average method, Thiessen polygon method, Isohyet methods. So the arithmetic average method. So this technique calculates area precipitation using the arithmetic means of all the point or area measurement considered in the analysis. So P is equal to like average precipitation over the catchment area is equal to P1, P2, P3. Like we have to add up to Pn values whole divided by n. That is equal to 1 divided by n summation of 1 to n Pi. So whereas P1, P2, P3, etc. Pn are the precipitations in a given time period at station 1, 2, 3, etc. n respectively within the catchment area. So the Thiessen polygon method, if there are n stations with rainfall, all values P1 to Pn and A1 to An are the area of the respective Thiessen polygons. The average rainfall all over the catchment P is computed as P1 area 1 like plus P2 area 2 up to Pn An whole divided by all area we have to add. That means area 1 to up to area n. So summation 1 to n Pi into A T divided by A. Like A T divided by A is called the weightage of factors. So this Thiessen polygon method. So we can take this entire area. Okay. So we can divide it into n number of particles. So n number of polygons. So see A is equal to total catchment area. So station 1 to 6 we can take. So see station 1, 2, 3, 4, 5 and then 6. So entire area it will be covered. So the bounded by then area weightage. So we can take A, B, C, D. So A, B, C, D we can take one polygon. From here the area 1. The area 1 we can calculate it through the point A1 divided by total area. So likewise the rainfall station A2 high subtotal 1. So the system counter fractional area we can calculate it like what we have seen the last slide. Then rainfall in each polygon, then weightage average area. So A into B we can calculate. Likewise we can take whole area. That's recognized by Isohyet methods. So the Isohyet it is a line joining point of equal rainfall magnitude. The catchment area is drawn to scale and the rain gauge stations are marked on it. So the recorded rainfall values for which area average is to determined are marked at a respective stations. Neighboring stations outside the catchment are also considered. Taking point rainfall values as the guide, isotype of different rainfall values are drawn, similar to drawing into based on spot values. The area between adjacent isotype is measured using a planometer. So if the sites go out of the catchment area, the catchment boundary is used as a boundary line. It is assumed that the average value of rainfall indicated by two isotypes act over the inter-isohyet area. This method is considered superior to the previous method when the number of rain gauge stations are large. So we can take n number of rain gauge stations. So the station rainfall levels. So see if the rainfall all values corresponding to the isohyet are 0.1 to 0.n and the area 1 to area n are the corresponding isohyet area. The average rainfall all over the catchment P is computed as P is equal to area 1 into 0.1 plus 0.2 divided by 2. Likewise, area 2 0.2 plus 0.3 divided by 2 plus etc. Last area minus 1 into point last minus 1 plus point last divided by 2. Overall divided by area 1 to area last area. Here A1 plus A2 etc. A n minus 1 is equal to capital A. So the isotopic method, the lower method, mean area rainfall, area between isotopic hectares, weighted mean rainfall average. So likewise, so see average isotopic method, area and percent area weighted based we can calculate. So this is the isotopic method. So rain data. So the typical used to determine rainfall at a gauge which is missing data or at a specified point of interest. So the normal ratio method, quadrant method. So first one we are going to discuss about the normal ratio method. So see the normal ratio method is equal to 1 divided by n, summation of I is equal to 1 to n and nm divided by ni into Pi, whereas Pm is equal to precipitation at the missing location, Pi is equal to precipitation at index station, nm is equal to average annual rain at missing data gauge, ni is equal to average annual rain at gauge, n is equal to number of rain gauges. So is used when the normal annual precipitation at any of the index station differs from that of the interpolation station by more than 10%. In this method, the precipitation amount at the index stations are weighted by the ratio of their normal annual precipitation data in a relationship models. The quadrant method. So quadrant itself, so the phase based we can so see the first quadrant, second, third, fourth. Based on the quadrant we can calculate it like it is used to calculate quickly the average rainfall for hourly time intervals. So the method takes into account the non-linearity of the rainfall distribution over the basin area. The basin is divided in a network of square elements with a fixed step size. The rainfall is calculated in each node using interpolation as a function of the measured value at the adjacent station. So see the quadrant method. 1 divided by summation of pi equal to 1 to n 1 divided by xi into summation of pi equal to 1 to 4 pi divided by xi, where pi is equal to rainfall recorded by gauge, I xi is equal to distance from gauge, I to missing data point, where the procedure we can find like a divided area around gauge of interest into 4 quadrants using record at nearest station in each quadrant, compute missing precipitation amount. So the double mass curve. So see the consistency of precipitation data. A double mass curve is used to check the consistency of a rain gauge record. So see in the here, okay, so 1988, 89, 90, 91, 92, 93, 94, likewise the cumulative rainfall at other gauge station, cumulative rainfall at suspected gauges. So k is equal to gradient of line before changes divided by gradient of line after changes. So the compute cumulative rainfall amounts for suspect gauge and check gauges. Plot cumulative rainfall amount against each other, divergence from a straight line, indicator error. Multiplying erroneous data after change by correction factor k. So gradient of the line before changes to the gradient of line after changes. So these are the reference link. Thank you. And these are the reference material. Thank you.